Assalamu alaikum dear students. In this video we are going to learn how to solve a linear programming problem in Excel solver. So for this I have an example in front of you. This is an example from section 2.4 and this is mathematical model of example number 1 in the section. So before getting into the solution we have to install the solver. So for this you have to go to options and then add-ins, and there you can find solver add-in. So if this is not already installed, so install it. You can see, you will see the button, installation button here, but I already have installed it, so I cannot see the button here. So get it installed and then get back to the sheet. So in order to use the solver, we need three major components from the problem. First of all, the variables, and then objective function, and then we need to write the constraints so that we can use this data afterwards in the solver. So first of all, let's write variables. So there are 5 variables in this problem. So let me leave the space for the variables. Then we need objective function. And this is maximization problem, so let's write max here, and after objective function we need to write constraints. So let's assign variables. So first of all, x1, because we have 5 variables, so x1, x2, x3, x4, x5. So these are the variables, and we have to assign some value to the variables to initialize the process. So I'm going to assign 0 to all the variables. You can assign any other value to initialize the variables. Now we have to write objective function. So for objective function, we can start with the sign of equality, equals. So let's write this objective function here, 0.026 times x1. So x1, value of x1 lies in this cell, so we'll click this cell, plus 0.0509 times x2. So this cell actually contains the value of x2, plus 0.0864 times x3. So here is x3, plus 0.06875, 0.06875 times x4, plus 0.078 times x5. So our objective function has been written. So press enter to move forward. Now we have to write all the constraints, and there are 4 constraints, and the 5th constraint actually is the non-negativity constraint on all the variables. So in total we have 9 constraints. So we'll write first 4 constraints here, and the last non-negativity constraints will impose in the solver. So we'll see those constraints later on. So let's start writing constraint number 1. Again, we'll start with the sign of equality. We have to write the expression on the left hand side of the inequality, and this is x1 plus x2. So x1 plus x2 plus x3 plus x4 plus x5. And enter. And this is the inequality less or equal, and right hand side of the inequality is 12. So write this 12 here. Now again, the second constraint, so we'll write left hand side of the second inequality here equals 0.4 times x1, and x1 lies here, plus 0.4 times x2 plus 0.4 times x3 plus this is minus 0.6 times x4 and minus 0.6 times x5, and press enter. Now the inequality is again less equal and right side of the inequality is 0. Now the third constraint, so start with writing left side of the constraint, 0.5 times x1 plus 0.5 times x2 minus 0.5 times x3. Enter, and the inequality is less equal and the right side is 0. So the fourth constraint, this is again, we'll start with the equal sign, 0.06 times x1 plus 0.03 times x2 minus 0.01 times x3 plus 0.01 times x4 minus 0.02 times x5. Press enter, and again we have less equal and the right side is 0. So these are the constraints except the non-negativity constraints. So now we have all the inputs of data. Let's use solver to solve this problem. So for this we have to go to data tab, and in this data tab you can see the solver here. So first of all we have to write the objective function here on top. So this is our objective function, so you can see the cell position written here, and we have to maximize the problem. So you can see the options, max, minimum, value of, so we have to check this maximization. And here we have to define all the variables. We have to so these variable lies from this to this, right? So B2 to B6 we have all the variables written. And what next? Next we have to add the constraints. So for this click this add button and start writing the constraints. So cell reference for left hand side of the constraint, we have this, and the inequality is less or equal. If this is not less or equal, you can change from here. And this constraint is the right hand side of the constraint. Add. Then the second constraint, again cell reference, the inequality, and here we have to add the right hand side. Add. And now third constraint, and we have to write the right hand side of the third constraint. Similarly, we can add fourth constraint. let me press add button. So add, and now fourth constraint, and we have this. Now we have added all the constraints, so we don't have any constraint left. So we'll press OK to proceed. So here are all the constraints, and now you can see make unconstrained variables non-negative. So you have to check this for making all unconstrained variables non-negative. So this is how we can impose the fifth constraint, the non-negativity of all the variables. So the next part is to how would we like to solve the problem. So our problem is the linear programming. So we'll choose simplex LP. And the last step is to solve. So let's solve. So here is the solution. You can see x1 is 0, x2 is 0, x3 is 7.2, x4 is 0, x5 is 4.8. So this is the optimal values of the variable, and this is the optimal value of objective function, that is maximum value of the objective function, right? So this is it about it.